Welcome to Lesson 2 of Exponential and Logarithmic Functions. In this lesson, we're going to solve equations with a common base. So, to start off, let's just take a look at this here. Now, it's very difficult to try and solve these. If we look, my x's are in the exponents. There's a problem, isn't it? How do I solve these? The only way I could solve these is if we have a common base. Alright? So for instance, if I have 5 to the power of 3 is equal to 5 to the x, well, this is the same as 5 times 5 times 5, and this must be 5 to the 3. These exponents must be the same. If I have a 2 there, that's not going to be the same as 5 to 3. This is 125. Then this here must equal to 125, because I said it's equal. So that must be to the 3 as well. So let's just go here and see some and practice some questions so we can get used to it. Here we have, same basis, 5 to the power of 2x plus 3 must equal to 5 to the 7. Well, 5 to the 7 can only equal to, if this was in base 5, 5 to the 7. So we know 2x plus 3 must equal to 7, because the bases are the same. Okay? So we just look at our exponents, they must actually equal each other. Okay, we solve, I get 2x is equal to 4, subtract 3 from both sides, and then I'm going to end up getting x is equal to 2. Done. Let's take a look at the next one. I have x minus 2 and, nothing. But we look at my bases, they're not the same. So in this one here, I must get them into the same base. So I'm going to assume that this is in base 7, and I divide it by 7 3 times. 7 to the power of 3 is equal to 343. Okay, so now I know x subtract 2 must be equal to 3, because 7 to the power of 3 must be equal to only 7 to the power of 3. So x minus 2 must equal to 3. Okay, so I end up getting x is equal to 5, and that makes sense. 5 minus 2 is equal to 3, which is 7 to the power of 3. And 7 to the power of 3. Perfect. Next one, we have 3 to the 5x minus 1 is equal to 81 to the 3x. Well, so the exponent's 3x, but 81 and 3. These are not the same bases, so we must make them the same base. So 3, 5x subtract 1 is equal to 81 is the same as 3 to the 4, and we have 3x. So 3 there. Now, this we multiply out, I get 3 to the 12x is equal to 3 to the 5x subtract 1. Now we just make our exponents must be equal. 3 to the power of something, if it's equal to 3 to the power of something, those exponents must be equal. So we have 5x subtract 1 must equal to 12x. And I'm going to take away 5x from both sides, so I get negative 1 is equal to 12x. Oops, sorry, 7x, so we take away 5x. So we get 7x, so I get negative 1 over 7 is equal to x. There we go. Let's take a look at the next one here. Now, I have two things that aren't the same. This one here, we have 3 to the x. I want both of these in 3's, so this is 3 to the 3. But this next one here, we're going to have to change a little bit as well. Okay? We have to, this is 3 to the 1 over 2. Because remember, this here is the same as 1 over 2. There's imaginary 2 there, imaginary 1 there. Okay, let's continue this now, and I get 3 to the x, the same as, well, power to product of powers, we're going to have to add this. 3 plus 1 over 2, which is 7 over 2, because this is the same as 6 over 2 plus 1 over 2. We need common denominators to add, which gives me 7 over 2. So we get 3 to the 7 over 2. Okay? Now, I know x is equal to 7 over 2, or 3.5, because that's 0.5 plus 3 is 5. But I like fractions. Fractions are your friend. They're nice. Okay, let's take a look at our next question. Question number 2. It says, a bacteria triples every 6 days. All right? The number of bacteria n present after x days is given by the formula this. After how many days is there 243 bacteria? So we want to know when n is equal to 243. So I have 243 is equal to 3 to the x over 6. Now, this makes sense. So we have to know when this gets that. Well, seeing as that's a 3, that probably is divisible by 3, and 3 to the power of 5 is equal to 3 to the x over 6. Okay? Because 243 is the same as 3 to the power of 5. Just keep on dividing this by 3, see how many times it goes, and you get 5 3s. Okay? Now, I know 5 is equal to x divided by 6. So then, multiply both sides by 6, I get 30 is equal to x. And that makes sense, because we're saying, well, 3 to the power of 5 must equal to 3 to the x over 6. Now let's put this in terms of the context, okay? It triples every x divided by 6 days, right? Every 6 days it triples, and it triples 5 times. Well, if every 6 days it triples, and it tripled 5 times, how many days went by? 30 days, and that just makes sense, okay? So that's essentially how we solve that one. Let's take a look at class example number 3. So solve the following equation by converting each side to a common base. Well, all of these, we're getting a little bit blurry there. Well, looking at this here, now that we're clear, we have 3 to the power of 3 is equal to 27. So 3 to the x minus 2, 3 to the power of 3 is equal to 27. I'll rewrite that so it looks nicer. So 3 to the 3 x minus 2. Now this here is the same as 3 to the power of 4. We have x plus 3. So let's simplify this here. I'm going to get 1 over 3 to the 4x plus 12. And this is going to be 3 to the 3x minus 6. Okay? Now, this is on the bottom. I don't like that. I want the 3 on top. That's like 1 over 3. So, I'm going to make it regular. So we have 3 to the negative 4x minus 12 all over, because I just put all this to negative 1, right? Negative 1. Oh, and this is 3 to the 3x subtract 6. Now I know this must equal to that. So I have 3x subtract 6 must be equal to negative 4x minus 12. Okay? So I'm going to put this on this. So I get 7x is equal to, and I'm going to get 6, and that's negative 6. So divide both by 7, divide by 7. I end up getting x is equal to negative 6 over 7. Done. All right, let's take a look at the next one. First thing I look at, there's a problem here. This is 6 over 5. This is 125 over 6. This is the bigger one here is on top. The smaller one here is on top. So I'm going to flip them. And by flipping them, I'm just going to integral it. So take out a negative 1. So we have 216 all over 125. That's to the negative 1. And then we have negative x, over 4. Which gives me 6 over 5. And we end up getting 3x minus 3. Okay? Now looking at this, I know 5 to the power of 3 is 125, and 6 to the power of 3 is 216. So I'm going to now get 6 over 5, both of these are to the power of 3, and negative times negative, well, is a negative, so I'm going to have x over 4. Okay, we multiply those together. It's going to give me 6 over 5, and we have 3x subtract 3. Now, we know my bases are the same, so my exponents must equal. Okay, so since my bases are the same, exponents must equal. So let's solve this now. I have 3x over 4 is equal to 3x subtract 3. Multiply each side by 4, 12x subtract 12 is equal to 3x. Okay, now I'm going to put this over here and that there, so I get 12 is equal to 9x. Divide by 9, divide by 9, I get 4 over 3 is equal to x. And that is my final answer. Hopefully you understood this. Good luck as I see you tomorrow as we work on this together as a class. Remember, if you have any questions, do not hesitate to ask and come up with some good questions if you want to go beyond what we did today. All right, see you tomorrow.